Hello everyone. In this lesson, we will look at some important properties of vector dot products. Now we know that two vectors, if A is dotted with B, this is going to be equal to AB cosine theta. So the dot product of two vectors is a scalar, which can be positive, negative, or zero, depending upon the angle theta. But one of the crucial things that you need to understand is a vector dot product is a scalar. And when you multiply a scalar by another scalar, all you have is a scalar. For example, if M bracket A dot B, this can still be equal to M A dot B, or this can be A bracket M. This can be equal to A dot MB. The order does not really matter. Now let me give an example. Suppose that you have a vector A equal to 4i plus 2k and a vector B equal to I plus 2j plus k. Now we have been asked to calculate, for example, 3a dot b. You can still represent this as 3a dot b. Now what is 3a dot b? 3a, which is just, you're going to multiply every term in a by 3. So this is just going to be equal to 12i plus 4k, and we will dot it with b, which is I plus 2j plus k. 12 multiplied by 1, this will give us 12, plus 0 multiplied by 2, this will give us 0, plus 4 multiplied by 1, that will give us 4. So this all together, this will be 16. So when you multiply a scalar by another scalar, you gain a scalar, or by a number, you get a scalar. Another property of vectors will be A dot B is equal to B dot A. The order does not really matter. We say that vector dot product is commutative. It really does not matter. And all of this is just gonna be equal to AX BX plus AY BY plus AZ BZ. Just like the formula to calculate the dot product of two vectors. Now another property of vectors is that if you have a third vector A plus B dot C, this will be equal to A dot C plus B dot C. The order here really does not matter, so you will just dot A and B sequentially if you're given this to calculate. Keep in mind that I dot J is equal to J dot K, which is equal to I dot K, which is equal to 0. The order does not matter, and the reason is because the dot product of two vectors which are perpendicular to each other is equal to 0. That being said, it means that if you have A dot I, you will have AX. If you have A dot J, you will have AY, and if you have A dot K, you will have AZ. This is another sweet property that you should also remember. Now the last thing that I would like for you to look at is how to differentiate a dot product. Now the derivative of a dot product, d of dt of a dot b. Pay attention now. This is equal to dA dt dot b plus a dot db divided by dt. This is the rule for differentiating a dot product, and please remember this rule. We are going to use it in the future. If you have any problem, please do not hesitate to ask in the discussion forum below, or send me an email and I should be able to respond to you within 48 hours. Thank you so much and remain blessed. Bye-bye.